Well, hello, everybody. Hopefully, you can hear me now. The music should have stopped. And welcome to this session online. I can see there's quite a few of the users. Say hello if you've not already said hello online. Hopefully, you can hear me now. There's a Gamer Brax. There we go. Never know who anyone is, but I'm not too bothered. So I'll wear the glasses just so I can hear some audio going on at the same time as this. May ask it a question every now and again, but who knows? So we're going to go through, see how it looks. Hopefully you like the setup. Gone a bit full YouTuber on this one, but thought might as well have a little go at this. So like I said, we'll try and check in every Tuesday at 4 o'clock for 45 minutes. Maybe not all that time, maybe a little bit longer, maybe a little bit shorter. We'll just see how we go. So why are we here? So we're here because we want to do the course Thinking Like a Coder from the British Computer Society. And it's a really good qualification because it will show everything that you need on a CV, that you are into technology, you know what's coming forward, and that you're keen as mustard. That's all we're bothered about. So, we had a little presentation just going over what the course is about and what we want to have a look at. And it really is just about that, thinking as a coder, not necessarily being a coder, although we will try and get some code through that. But we're going to have a look at some of the introduction, the objectives, some benefits of why we're going to do it. This does have an actual certification, so it's worth remembering that you will get a qualification out of this. Completely online test. You can have a couple of goes. It's hopefully get it right first time, but it's not a high pressure stakes exam like GCSEs. And you can do this at any year group. It doesn't matter if you're in a GCSE year group or not, but it's at that level. We call it about a half GCSE is kind of what I would say for this. And we're going to try and get through this in the 15 sessions. That's kind of the aim for this. We may do a little bit longer if people need some extra revision help, but this is kind of where we're going with that. So computational thinking is a really useful skill that people are asking for these days. So what we're talking about here is not just coding, it's thinking like a coder. And the skills that we have are highly sought after in businesses right now. And to think as a coder, we are going to use those techniques to analyze and solve problems. So we're going to design, write, and test simple computer programs as well. And you don't need a laptop to do this from home as getting the messages. I'll try and respond to the messages in the chat as I can. So let's see how we go with that. Let's make sure that the comments, I don't have to keep people or boot people out of this, because I will, and I can see them as I go through them, and I will go through and I will take messages out as I need to. So I will go through and I will check out messages as I come through them. So let's just pay attention to what's going on, everything that's being said, okay? Otherwise I will block people. It's possible. I've remoted this to 1 minute timeout, so people can't hopefully spam this going forward. And I'm just going to have a little just delve through the comments as I go, as I've removed one. So, we are trying to keep this lightweight and quick. So hopefully the question's there to guide me, and there's about a 20-second delay, so I will get them through. Slow chat is annoying, but it'll stop people from spamming through. So the next thing going through is, when we've got the objectives here, we need to simply understand key concepts when we're programming, and we will want to write, test, or modify some code. We're going to use something called pseudocode, which is not quite coding. You can just get your answers down. So while I will give examples in Python, sometimes JavaScript or HTML, what we don't want to do is we don't want to get hung up on that syntax, those little details. So as long as you can understand the ideas of looping and doing all the problems that we come through, we can basically get through this without having to know the little bits and bobs through that. So the programming that we're going to use is mostly Python, because it's quite an easy idea for that. If people do want subtitles, you can go to the little cogwheel at the bottom where it says settings, and there's a subtitles there. Oh, is it not switched on? I see that. Very good comment from there. So I will change that in the edit for them going forward. The subtitles will be on going forward from this, and we will change that in the editing. It may well, I think it's actually, There we go. It's because I haven't done a live in a while. The subtitles don't come on because it can't do the live translation or the live text. So what will happen is after this session is finished, the session will be recorded and you can play this back. And if you're coming to this late, it doesn't matter. But those subtitles will then appear about 10 minutes after the final recording. So I think I'd press the setting off there, but it's just a reminder of what happens with live translation. So we will go through and we will test and debug and learn how to problem solve with this. The benefits of the module is that you'll show to employers in a CV that you are decent with digital skills. Not just decent, a little bit more than that, that you've got that kind of desire to do a project outside of school hours as we're doing now. And that will say a lot about the kind of person that you are, in my opinion. So really good to have this on a CV. And the skills will there for general problem solving, not just computer coding. For example, the setup that I have here, I've got 3 screens going on at the same time. I'm trying to keep an eye on the chat on one screen. I'm making sure that 20 seconds later, I'm seeing everything that's coming through. I'm listening annoyingly to 20 seconds worth of chat behind me. I've got cameras at the top. I've got other modules in the side, and I've got lots of different things going on. I had to solve the problem of how to do this while presenting on my own and deconstructed the problem, as we'll come to here. So computational thinking is not just about being able to code. The certification outlined in a piece of text that we'll be giving you, a kind of online book as such. It's an international standard called Thinking Like a Coder from the British Computer Society, and it's known as a kind of driving license online. The syllabus map, the projects that we need to get through, we've really touched at them a lot when we've done the kind of trial session at La Rocquiere School, because we've done a lot of the programming and a lot of the stuff that we talk about here. We haven't talked about it exactly with the words that we're about to do here now, but when we look at it, we will talk now briefly about what it is to think like a coder. We'll talk about software development in the next session, algorithms, which just means the code and the problems that we're doing, how to get started with Python. And also what we have is the data types and variables, true or false statements, data types, enhancing your coding, conditional statements, which just mean if, else, or what happens if these targets are met. Procedures and functions, which just means making a slightly more complicated, like the Create Your Own Adventure tool that we already did in the test. Loops, which are really useful to keep going over and over and over problems again and again without having to write loads of code. The libraries that we talked about, like the math library and everything else, and then just testing and modification. So we have actually touched on most of these projects. So I don't think you'll find it too difficult getting through this, as we have done quite a lot of it. All we need to get you through now is the online testing. What words do you need to know? What multiple choice items do you need to know? And you can go back once these sessions are finished. There'll be a little bit more formulaic after today and the getting to know you part, and it will just be, here's the answer for these, and we just get through them and you will learn them, and then we can do the online tests to go with. So what I'll have a look at now is I'll now come to my full screen mode for this, my cam and screen. So there it is. I can move and I can take myself off if I get in the way in a minute, because once you've seen me, you don't really need to see me much more than that. And I will just stop that PowerPoint now. So the first thing to have a look at, and I will zoom in and when appropriate on this, is how do we keep coming back here? So the easiest thing to do is remember that in Digital Jersey, we've got the online session. We will probably test Teams if we can get that working. I know we've tested it a few times, but we'll probably see if we can do that. But for them now, if we come on a Tuesday to Digital Jersey's YouTube channel, you will be able to go straight to the live session, which was the same link as you've got here today. And when you see the live, as you can see here now, I am live, and that's the one. We've also done some lunchtime sessions with Microbit. If you're interested in those, that's me talking through that. But these sessions will all be found here, and it will tell you the date of the next one with a countdown of what's to come. And then you can click on those and join that. So the easiest way to do that is just by doing that. So what you'll also see in the information below, I'll drag it in actually just to show you, although it's be a little bit weird because it's really far behind. So in the comment section, there is a link to a page, and that link will take you through to this, which is the Thinking Like a Coder website. I think it's an easier way for me to collate some information and send you the links of where to go. So if you don't remember anything today, you can remember the site. I'll use the big text here that I use sometimes. Big text. I do like this when I'm demonstrating the large type. And the only website that you need to know, other than hello, is digital.edu.je. So if you wanted to pause this or write something down, the only thing that I think you need to remember, apart from the content that I give you now, is this digital.edu.je. Because when you type that in to the web browser, as I'll do now, it will take you to this site, which has all the information. There we go. It's the same one. It does a little redirect to this page. And I'll add more and more information on as we progress with this. But what we can do is, if you click on this live link, for example, it will take you to that page I've just discussed, making everything easier. And we've got some learning materials, and I'll talk about that in a moment, which takes you to the Thinking as a Coder space. Remember, you have to log in with your school account to do that. So go to login, click on Microsoft and log in through there, and we will have access to more learning materials, not for today, just for the other sessions when we go through. And I might do some quiz me, some think alongs as we go. So today, when we go to the quiz me, there will be a short little quiz that you can click on and have a go at, and you can write your name and school, and you can have a go at the questions that we're going to go through today. You might want to do that now and test yourself, and then come back and test yourself again after the session, but I will trust you to do that at the end of the session. So as I said, I think the one thing that you need to remember, and I'm sure you can, is digital.edu.je. I'm sure a teacher will remind you about that, and I'll remind you every session when we come here to do that. If you fail to do that, Digital Jersey's website with the live section is what we need. So let's have a look at what we're going to have a go at today, which is, like I said, computational thinking, and the session's laid out about why we're going to do this. Now, we will put links on that other web page to show you what computational thinking is, but really what we're talking about is this idea here about the kind of four main sections about what people in business really want young people and employees to have in the modern world. And for us today, that is abstraction, algorithms, pattern recognition, and decomposition when it comes to thinking like a coder. What does that really mean? Because it all sounds quite complicated. What that really means is, can you take a large question and break it down into smaller and smaller pieces? So, for example, in a maths question on an exam, you might get lots of broken down part A, part B, part C's. How do I paint the wall? Do I have enough paint to do that? But what we'd prefer you to be able to do in computational thinking is not have those questions broken down for you into sections, is for you to be able to break them down yourself. So if I'm looking at the room I'm in with all the walls and the one behind me, which has a curved to make it even harder elements to it, how much paint would I need to do that? Well, I'll need to go and I'll need to take my tape measure, my trusty tape measure, which is never far away, and measure all the separate walls, break them down into how much paint per wall, then work out what one paint bucket will, or paint pot will paint, and then divide it through and break that problem down. Or can we think slightly differently? Do we need to abstract this question? Do I need to go down and work out, pardon me if I knock that, there we go. When I go back to that wall behind me, which is curved, then I need to start thinking about, well, how much of it is curved? Is it a quarter? And we start to do that. Other things are pattern recognition. Can you spot patterns easily to be able to program them? And algorithms. Can we write a series of instructions that I will be able to follow in that kind of pseudocode example? So really, the whole problem about the first step in problem solving is identifying the problem. You need to be able to identify it, then look at it as a whole and break it down into parts, as I've just kind of described there. We're going to be using pseudocode, which is just really a step-by-step plan. And we're going to use the term algorithms, which just really means a set of instructions. And with the pseudocode to break down those set of instructions in to that plan. We're also going to test our code, our pseudocode, see if there's any problems, plug it in, have a go. And to do that, and feel free today to follow along as I come to it, use Trinket. We've used it before, and if I come back into here, in fact, what I'll do is, because I'll remind people about that one in the end, let's come back in here, and let's go back and go to Trinket.io, and that will take you to a website, but we're going to use /Python today. So while you don't have to do that while you're watching along here, what I will say to you is, if you want to, just scrolling my page in and out there a couple of times, lost my mouse on my 3 screens. There we go, got it back. If you want to follow along as I'm doing it, you can, or you can just watch, or you can watch this back later at the re-recording and have a little go. So I definitely, as I said, I'm always going to be about a minute behind the conversations. We always have a tape measure on my desk. In fact, I've got better than the tape measure. We have a pair of calipers here as well, because I'm always 3D printing, measuring, doing devices, making things, as well as coding them into physical items. I take a lot of electronics, then I can make a device to fit those electronics into, design them, always measuring, always doing different things for the making part, not just the programming part as we do here. So Trinket.io/Python will take you to this page. In fact, not that one, that's HTML, this page. And sometimes it looks a little bit different to this. And all you do is remove all the code, press play, and nothing will happen. So that just resets you ready to go. So when we're going through all of this, and we're going to have a little go, we can just follow and get the ideas, because you don't have to get this exactly correct. You just have to follow the idea. Now, the very important thing, and everything that I'm saying now will be in this little quiz if you want to have a go at in a moment. And we're having a little go here, and I'm going to use the little hash key first. I'm going to zoom in as far as I can go with this. There we go, a little bit better. I'm going to use the hash key here, and I'm going to write my first program. We use comments because it helps other people to follow our code. So very, very important to do that. It's not essential. It doesn't make the code break or anything like that. Comments are there just to remind you about what goes on later on. And I'd be wrong if the very first lesson you see most people do is something called Hello World program, and we do print, which we've done before, open the brackets in Python, open some speech marks, and you'll see they're both closed afterwards as well, and we do Hello World. And then when we press play, it's at the bottom here, so I'm just going to stroll up. There we go. We have our Hello World. And that is the very first thing that we ever do. Now, syntax means the kind of programming code that we have here. And when something goes wrong with syntax, it just means the way in which the code is written, the structure. Now, in pseudocode, you're going to be able to get away with the syntax. So in JavaScript, for example, we would end with our colons or semicolons in here. Not necessary for pseudocode, but that's what happens when we say it's a syntax error, because we would go down and it would start to have X's and crosses when we get things wrong. So we need to know what a syntax means. It just means the characters and the way it looks. But don't get too hung up on that. It's just a word that we use to do that. So the next thing that we're having a look at here is what is the we mentioned what is the comments purpose, just to instruct people, and you can have as many of those as you like or as you go through, because I can just press enter. I can press my, on a Mac, I have to press Alt and hash, sometimes on different computers different ways, and write as much as you like. There we go. And it doesn't even matter about spelling errors. It does with code, but it doesn't matter with your comments. So we've got the purpose of that. Now, the next thing we're going to have a look at, and I'm going to get rid of here, are variables. If I was in JavaScript, I might start off with var for variable, but I'm in Python, so I'm just going to do x equals 4. Now, that immediately might put some people off because you're there going, hang on, I knew I didn't like code because I don't like maths. Stop thinking like that. Maths is a useful skill. Of course it is. I was an ex-maths teacher. Please forgive me for all the pain that I caused my ex-students. But maths is vitally important, but not completely and utterly necessary. You can be good at coding and not good at maths. It does help to be good at both, but it doesn't mean if you don't think you're strong with maths, you're not going to be strong with coding. I only use X because I'm used to doing that. I could have removed that and just called it number 1 equals 4. I could just say that. And the reason why I'm saying number 1 is because I might want to put another variable, which is just something that changes, okay, to store and manipulate data. I might put another number in here, which is the 7. So the variable can look like anything, any words. We try and avoid using special characters and dots and spaces. We try and use what's called camel case a lot of the time. And if you think about a camel, that's just the humps of a camel. And I would put something like num for number and number var 1, something like that, number variable 1. Dashes are okay. Underscores are also okay. So that's a good question to ask in the chat there. But we can use whatever we want. But by camel case, we usually start off with all lowercase and we use capitals to separate words. So I could have a really long example of camel case is this. And you can see that we've not used spaces to separate our text. We've just used the capitals to make it easy to run. Now, that would be a terrible variable because I would have to write that every single time. So we try and keep our variables as short as possible. So the reason why we use X and Y is because they're short. Now, you don't have to use X and Y. We can use A and B. It's just historical in mathematics. We use X and Y because we do a lot of stuff with graphs. That's all it is, X and the Y. Or otherwise, wrong way around there, isn't it? Y to the sky, X is across. Should know that. You can see I'm out of training as being a maths teacher. So you can use any letters to do that, or words, or shortcuts of that. So while I've kind of gone over that point a lot, it's important that we remember that variables are not there to confuse us. They're in fact there to help us. So if you prefer longer variables that say things like num var1, by all means do that. But for the purpose of today and speed, I'm going to use shorter versions of that. So we've got our variables there, but they're not doing anything right now. And we've still got the word hello world in here, and I've changed stuff. So what's going on? Well, I haven't pressed play yet, and I can press play, but all I've done is tell the computer that I've got A and B. I don't have anything else. I haven't told it to print the answer. I haven't even told it to do anything with the answer. So what I might say is answer equals, or a shortened version, ANS, to do that. So I'm just going to do ANS equals A plus B. And if I press play, again, I may be expecting to see 11 pop up here. Again, I haven't said print. So afterwards, I would need to do print and then ANS. No need to do the speech marks now because we're not dealing with text. If I do the speech marks in here, we have said print this string, this word. String just means a word. And so that would say ANS. It's literally typing what I've said, which is ANS. If I remove the speech marks, it's no longer a string. It is now a variable that I'm asking it to print. And when I press play, we have the 11. So there we go. Very good. Game of Brax there. Do print A plus B. Thank you. Ahead of schedule. I'm just like I said, about 20 seconds behind you when I do this just because of the streaming. So all really well. So important to understand that variable. Now, if I put in the capital in here, you'll notice that it's gone wrong. Capitals there are not good, okay? So you need to make sure that we have the lowercase in there. It is important when we do that. So we have our variables, which are used, again, I say it, I'm hinting to you for the quiz that you can do after this, which is we are manipulating data and we are storing it as well in here. We've stored the A and the B, and we can change those values and press play again. Yes, we've got the math as well there. Excellent to decide that. Now, because I'm just doing variables and I'm not using things like random and stuff like that, I don't need to import a library of maths just yet, or math, because we're in England, because the basic functions of add, times, divide, and all those things are considered to be so standard you don't need a library for it. And we'll come to libraries at a later stage. So when I press play here, or the play icon, now that I've changed my variable, I have the 21. If I come in now and do a times instead of a plus, we've got the 98. So that's why you don't have to be good at maths. The computer's doing the maths. We just have to understand what we want it to do, or what we want it to ask us to do. And that's what's happening here. Remembering that divide is a /, and we're going to get some, I picked a good number there, 14 divided by 7. So obviously it's going to get the 2. If I choose an awkward value in here and press it, it will do the decimal places to a point. So you don't need to be good at the maths. You get the computer to do it the maths. That's why we should love coding. The thing that we need to talk about as well, just because it's a word that we need to know, we're kind of talking about a method here. We're not really talking about a function. We're talking about a method which is here to do some work. A function is something when we associate it with different objects, which we'll come and explain on a later session. So we're not really doing a function here. We're just doing a short series, a short algorithm, which is more of a method than anything else. So they're standalone, and functions are associated with objects. The next thing, and the last part, to do with like the quiz that I'm going to ask you to do at the end. Yes, arithmetic. Well done there, Michael. So when we're having a look at this, the other thing to look at are loops. They're important because you can get the computer to do lots and lots of things for you without having to get you to write that code. And it can be really helpful when trying to problem solving, breaking problems, sorting algorithms. You'd be surprised how many times a computer loops through variations of problems. So it's one of the most important things that we have. And it's not that bad. And again, you're not going to need to get this perfectly right each time, as long as you get this basic idea for pseudocode. So you might want to, in pseudocode, for example, say four times, or just, you could even do this before, 4 times do the following. And then you could say what that is. Okay, now it's not the greatest pseudocode in the world. I prefer us to, while we don't need to necessarily know exactly how to do our pseudocode, I would like us to try and keep as much to code as possible here. So what we're looking at is, I'd prefer you say 4x or 4 better, 4i, which just means iteration or over and over again. 4i, and you can say in the range 4, maybe just do it like that. The perfect way of doing that would just be for I in the range, and we use a bracket to say it. That's the perfect code for Python. But you can use the words or variation when you're writing in the online test or online exam. The idea is to get the idea, not necessarily the syntax, the exact comments, because we've also got colons and things like that we need to add in. And you'll notice that when I press enter in Trinket, it automatically puts the tab in for me. And I'm going to say print I. So what this means is, can we loop around a bit? And I'll zoom in a little bit more now again, just so I could see something on the other screen there. So we're saying now, for iteration in the range 4, in other words, 4 times, can you print I? And when we press play there, we get something a little bit odd when we're talking, because we're so used in human nature to count with 1 as the first number, 1, 2, 3, 4. But computers deal with binary, zeros and ones. And for a computer, the very first number that exists is 0. It's an important thing to understand, because if the exam came up and said, and it could have done it in pseudocode, and it said for the range, for the range 4, without all this code in here, for the range 4, what are the first numbers? Print numbers, something like that. If you said 1, 2, 3, 4, you would get that wrong. It is very, very important that we understand that the range, and I'm going to, hurts me to see it not in the correct form, for I in range 4, when we press that we see those values. Now, again, if we do things incorrectly in Trinket, which is why I love it, we have to make sure that we've got it all written correctly for I in range. And what we've got there coming forward as I zoom in and out to make sure we can see this perfectly is the concept here that I had it correct, but what am I missing? And this would be a syntax error. I'm pressing play. I'm getting the wrong things. I've checked any spaces, although you can have more spaces than you require. I'm checking, was it in the simple thing, colon at the end. So if I do range 8, what I'll ask you to do in the chat is work out, not range 8 actually, if I do, because that will be too much in the chat potentially. So if we go in range 2, what numbers would pop up if I did in range 2? And because there's about a 20-second delay in the time it takes for people to write in the chat, I'm going to stall massively while I do this, going through, see how many people can get the answer for this. What numbers will pop up here? Just don't need to put them on different lines. You can just write the numbers out. So for example, if you think it's going to be 6, 7, 8, 9, you write that in there. You'd obviously be wrong, but it'd be interesting to see how many people could get to that answer. So I'm looking at both screens, the one that's behind in time and everything else, to see if people are adding it in there. Yes, we definitely start with 0, I've seen in the first comment, but there we go. We've got the first right answer. Well done there. So just to prove that, there we go. And everyone's rocking in straight away with that. We've got the 0 and the 1. So well done for those people. Because the 2, it does mean there will be 2 numbers. So at least you'll get that right when you'll see there will be 2 numbers. And you just need to remember in our minds, as everyone did, the 0 is the start. So well done for those comments, and very pleased that people are getting that. So we have gone through what I would say is most of the pure content for the test that I have. We will go into longer sessions, and I'm going to show you some extra parts to finish off for the last 10 minutes here. And the last thing I would like us to have a quick little look at, though, however, is conditions. Because I think while loops are important, I think actually when you start out your code, you look at conditions way more than you actually use loops when you're first starting out. So I'm going to do a basic one in here. And again, like I said, you might want to put your code in. And I said, I'm making, or an example of a condition that we have here. And all conditions start with if, okay? If, and you come up with a little scenario, a little idea that you might want to have. So if, and then we start with the condition itself. If, and then to do this, you'll probably need a variable to start off with. So let's call the first one number equals 10, right? So I'm going to say if number is greater than 0, and because we've got an if, we're going to do the colon. But remember, in pseudocode, don't worry if you keep forgetting that. If you think, do you know what, I'd forget that all the time, that's fine. We'll go through some code, but you can definitely don't have to get it for the pseudocode part of stuff. So when I press enter, there's a tab. Because one thing I'll show you again, which I didn't show before, if you do not do that tab, it will not work. If you'd write print in here, you won't get it correct. So it's easier to press the enter and keep that tab in there. And I'm going to do print big number. Now I want text here. So there we go. And if it's greater than, not 0, sorry, greater than 10, then we're going to have equals great number. Or we could change it to say, if the number's greater than 0, it's positive. Like that. So we could have a guessing game and we could include negative numbers for that. And your clue might be whatever the starting number is, it's a positive number. I mean, it wouldn't help you much because there's an infinite number of those. But we've got the idea of a concept here. And when I press it and we press play, say it's positive. Now, if I write -1 into here and press the play, nothing happens because I haven't written an else condition for that. I've just said if the number is greater than 0, it's a positive. It's just a single condition that happens, and we like to have lots of ifs and lots of if-elses. So I'm also going to do a 20 just to prove that it works. And what we often do when we're testing, and again, we're going to talk about testing in its whole other concept, is we usually test what we say just before, on, and just after the problem. So if I was going to test, and again, I'll stall slightly and see if people come up with the answer. If I was going to test this problem, what is the key number? Think of what the key number is in the condition, what's just before it, just after it, what 2 numbers or 3 numbers should you choose? In fact, in this example, I'd probably even go to 4. There's a reason for that. So I'm going to stall slightly. Okay, so if I look at this number, what is the little one beforehand? What is the one in the middle? What is the one afterwards for good testing of this number? And I'm going to go in and test this variable in here. So I'm stalling slightly while I'm trying to keep up with the 20-second delay on the chat. Come up with some good examples of me to select as a good test for this particular problem. So there you go. Yeah. So if it's less than 0, you say it's wrong. I mean, it's not wrong. It just doesn't do the condition. Okay. It just doesn't solve this condition. This says if it's greater than 0, something happens. But what is a good place to prove what's going on? So I've stalled long enough. So I'm going to give some examples. The key number is 0. Right? So I need to test 0 itself. What happens when 0 is tested? So I press play. Nothing happens. That makes sense because I said if the number is greater than 0, and 0 isn't greater, it is. So the next number to choose would be a 1 because it's greater than 0. There we go, it's positive. And we go just below like a -1 just to prove it's okay. And there we go. So that's the number. Now, you could argue that maybe you should have done a 2 as well because greater than 0 is really 1 as the first number. So I should also really test 2 as well. So yeah, just asking there, if number equals 0 or under, then it's either 0 or negative. Now, 0 isn't a positive number. Right? 0 is neither negative nor positive. So we could have greater than or equal to 0. Now, that would be a wrong statement here because now it's saying that 0 is a positive number when it is neither. So that was the example for that. So good comments there. Well done for that. So I'm going to stop there on the kind of explanation. We are going to get faster and quicker as the sessions go on. I just wanted to get people in the habit of coming to here on a Tuesday for the first session, knowing where to go. So I did some very basic stuff to start off. So thank you for taking part with that. Remember that the one place that you need to know is digital.edu.je. And if you click on that now, you can have a go at this quiz where it says, so you can go to digital, like I said, digital.edu.je, and you can go to the quizzes section. So the homepage just looks like this. You can go to either Quiz Me in the top corner here, or you can click Quiz Me here. If I zoom in a little more, just got a Quiz Me icon, and if you click that, it'll take you, and these will beef up as we go through the sessions. And if you go to computational thinking, you can have a go at this quiz. Put in your first name, put in your last name. The drop down is Laroquiere, but if for some reason you've persuaded somebody else from a random school to join, they can click other, and then you can have a go at the test and it will mark it for you. I will just do some last minute pieces for the last few minutes. So if you're having a go at that test, I might well hang on while that's happening and just see if anyone answers it. I'll be able to go in and see that while it's live. Or if you're doing this as a recording, you can go back through it and have a look. So do remember that the same location that we said, which again is in Thinking Like a Coder, which is in the live link section here, will take you to this page. And when I finish this session very, very shortly, that will change and be recorded. And then the comments will come up in about 5 to 10 minutes when it's worked those out. And this will start to be a bank of all of those sessions that you can go back to at any time. So if you miss a session, great. You can just carry on and do it, but try and get here live and take part in the chat as you've done very well. Thank you for listening at the beginning when I thought things might have got slightly out of hand. Thank you very much. But have a go. So that's all good. Have a go at that test. I will sign out by going back to, I think I've got another little intro section here. Look at that. I've got all these little different YouTuber type things going on there. I'm just playing around really. And just for your own information, the background was made using artificial intelligence. Just had a go at some of that using the Google Gemini to have a go and see how that works. So I will stay on and kind of fill some time. Feel free to go now, all's done. I will do also, that's a good example, Go Bananas there. I will make a playlist for this. In fact, I do have a playlist. I'll go back quickly as I was just about to sign off to that. So great example. There is a playlist in here called Education. Somewhere I'll make sure that it's more prominent, but I did have an education one or slot in here. I will make sure that it's live. I've probably done it as a kind of draft version of that. So yeah, good example. I will make an education playlist on the channel for us to go through there. So great example. That, not that one, intro. That's the exact reason why I'd like you all to take part in the comments, because things like that, I will listen to those comments and I will add those into either future sessions or to the website that's more helpful. So thank you all very much for listening. I've kept to the 45-minute section. Hope you liked the little intro start. I'll try and do some more interesting things for that 5 to 10 minutes beforehand, but it just means that you can log in. There'll just be music playing in that background, so it will just be me and my face telling you to make comments and do the like and subscribes. So if you haven't liked and subscribed, please do so. I should always get into the habit of doing that. Any good YouTuber should, but I don't think I quite qualify as a YouTuber. I've not got near the subscriptions or anywhere near it, but we appreciate all the likes and subscribes. Carry on going, do that quiz. And if you wanted to go through it again slower with the subtitles, come back in 5 to 10 minutes. And don't worry if you miss a week, but do try and make it live every Tuesday, 4 o'clock, and pass it on. And even if people weren't at the sessions that we were in with the teacher, Mr. Osborne, invite them. Even if it's another school, invite them. We'll start to try and make a list and make this a thing every Tuesday. Bye. Love to see you all. Until the next time. And I need some end music. I think I'll work on that. But for now, I'll just go bye-bye.